Hello, this is Roger Cook at Resources for the Future and the TU Delft, and I'm going to give a simple little video about decision making under uncertainty. And I'm going to illustrate that with the current issues surrounding climate change. This is a very big problem of decision making under uncertainty. And I'm going to focus on pitfalls into which we can all fall when we try to reason with uncertainty. And these pitfalls are illustrated strongly in the climate change debate. So that's the subject of this little video. This talk was given at Zurich in December of 2018, and there will be a link and you can watch the whole talk if you like. Okay, so let's get started. This gentleman here, Steve Koonin, proposed in 2017 that we should have a red team, blue team exercise to deal with the uncertainties in climate change. And this idea has been adopted by the Trump administration. They've never really moved forward with it, but they keep talking about it and they keep suggesting they want to do it. So, how would this work? Here's what Steve says. The focus would be on a published scientific report meant to inform policy. A red team of scientists would write a critique of that document, and a blue team would rebut that critique. So, this idea of red team, blue team comes out of war games in the military, and the Trump administration is proposing to use this technique to resolve the uncertainties in climate change. That is, you let two teams go at it, and whichever team prevails will then represent the prevailing point of view. And to some people, this does sound reasonable until you imagine what a soccer game would look like if it were played in this way, a game that I will call Koonin soccer. So here's how it works. You have this blue team over here, and you have the red team over here. And the blue team has this thing here called a goal, and it has a goalie, and he has to defend this goal. The red team doesn't have a goal and doesn't have a goalie. They only have to attack. So you might ask, why doesn't the red team have to defend something? For example, why don't the climate deniers have to defend the proposition that doubling CO2 concentrations in the atmosphere poses no risk for society? Why don't they have a claim to defend? Well, that's the whole business of this war game. And so the real question is, why would anyone want to play Koonin soccer? At least, why would anyone want to play the blue team in Koonin soccer? And I'm going to suggest that the reason for this is an error in reasoning under uncertainty that is very prevalent in the climate debate called the confidence trap. And how does this work? It will be illustrated with these two characters, John and Jane. So John says, it'll be a huge day. I'm highly confident that my car won't get ticketed. I'm highly confident that the sun will shine. I'm highly confident my team will win. And I'm highly confident that my portfolio will go up. So Jane says, so you're highly confident in no ticket, sunshine, win, and portfolio up. And John says, yeah, well, that's what I just said. Jane says, well, no, it isn't. She takes out this die here and she says, I'm highly confident that a six won't show up on the first throw with this die. I'm also highly confident that it won't show up on the second throw, and on the third throw, and on the fourth throw, but not on all four throws. The probability of no six in four throws is about 1/2, and that's not high confidence. So we can understand this with these simple little Venn diagrams. It's all really obvious once you think about it in the right way. So let's draw a random point on this blue circle here. And let's say that, I'm sorry, on this circle. And if that random point is blue, then we'll say the first proposition is true. If the random point is blue in the second picture, then the second proposition is true. And similarly for the third and the fourth. But are all four propositions true? For that to happen, our randomly chosen point has to fall in the blue areas of all four of these. So to find that area, we take the intersection of all these blue areas and we find that it's this area here. So in this case, it's still pretty probable that a randomly chosen point will be blue and they will all four be true, right? But could just as easily look like this. So now a random point is very likely to be blue in this circle, and in this circle, and in this circle, and in this circle. But how likely is it that a randomly drawn point on this circle will be blue on all four of these? Well, that's down here, this little area, and that's not highly confident at all. So Jane says, look, it all depends on how your confidences are stitched together. Just telling me you're highly confident 100 or 500 times really gives very, very little information and doesn't give the relevant information. So let's illustrate this with the climate change debate. Here is an example of reasoning under uncertainty with IPCC's calibrated language. And this comes from the US National Research Council 2010 report, Advancing the Science of Climate Change. And this is really in the regime of the fourth assessment report, and there are some small differences in the fifth assessment report, which I will address in a second. But here's how they reason. They express their conclusions as a number of propositions, and with each proposition, they give their confidence rating. So the first is the Earth is warming. Well, we don't know that for certain, but we're highly confident that the Earth is warming. Second, most of the warming over the last several decades can be attributed to human activities. We're not entirely 100% certain, but we have high confidence in that one too. And then climate variability cannot be explained or offset the long-term warming trend. Again, we're not entirely certain, but we're highly confident, and so on and on. Everything highly confident, you see. And so here they are illustrating their reasoning under uncertainty by concatenating this sequence of statements for which they claim high confidence. And Jane comes along and says, well, which is it? Is it this one or this one? And so you see, the problem here is that this information is simply not the relevant information that we need. Not only that, this National Research Council is populated by people at the top of their scientific food chains. And it's bad enough that they reason incorrectly under uncertainty, but they teach other people to reason incorrectly. And it gets even worse. So in this calibrated language, if we think there's a probability between 99% and 100% of an event occurring, we can say we're virtually certain. Well now, suppose the US Nuclear Regulatory Commission were to license nuclear reactors based on the finding each year that they were virtually certain not to fail. Well, with 100 reactors, and each having a probability of 1 in 100 per year, well, do the math. And by the way, to do the math, you have to know how these probabilities are all stitched together. So you can imagine how someone who's trained in risk and reliability will look at this example of reasoning under uncertainty and just take a very deep breath. Try to imagine the chasm between the way in which professionals in risk and reliability think about uncertainty and how we are taught by the IPCC to reason under uncertainties with climate change. And the big example for all of this is equilibrium climate sensitivity. This is the amount by which the surface temperature of the Earth will eventually rise after doubling the atmospheric concentration of CO2. And here's how they express this uncertainty to the general public. They say it is extremely unlikely, that is to say less than 5% probability, that this temperature rise is less than 1 degree centigrade. And in that statement, we have high confidence. It is very unlikely, not extremely, but very unlikely, that is to say 10% probability. It's very unlikely that the temperature rise will be greater than 6 degrees, and in that statement, we have medium confidence. So for context, let me just take a quote from David Archer, who was one of the premier climate scientists at this time, and he has said a climate change of 5 to 6 degrees centigrade would be catastrophic to human civilization. So we have an event that is catastrophic to human civilization that is very unlikely to be greater than 6 degrees centigrade. And in that statement, we have medium confidence. So let me ask you this. Would you put your kids on an airplane in which the authorities had medium confidence that the probability of a crash was less than 10%? You can say still it's extremely unlikely. It's less than 10%, right? Would you put your kids on such a plane? Well, these degrees of confidence have been backpedaled a little bit in the fifth assessment report. Now, the fifth assessment report contains the following sentence: the natural language is not adequate for propagating and communicating uncertainty. Only we still don't know, from the IPCC at least, how that should be done. Only there is this statement that the natural language is not the appropriate vessel for doing that. And these confidence statements are just a qualitative synthesis of an author team's judgment about the validity of a finding as determined through evaluation of evidence and agreement. Well, we know this method. This is not new. This has been around from the 60s. At least the name of this method has been around from the 60s, and it's called the BOGSAT. What is the BOGSAT, I hear you ask? Well, BOGSAT stands for bunch of guys or girls sitting around a table. This is the oldest method known for quantifying uncertainty and the least reliable. And so this is what leads us, in my opinion, to play Kunin soccer. In other words, this BOGSAT method leads us simply to concatenate these statements of very high confidence, and the confidence trap then leads us into thinking that we should be highly confident in the whole bunch of them, and that leads us to accept the extremely lopsided burden of proof that the blue team carries in a Kunin soccer match. So the final question: would you put your kids on BOGSAT Airlines? So the idea is the bar needs raising. We have to improve the ways in which we discuss and reason under uncertainty. And of course, the course which you are about to follow is going to go into that in great depth. And the answer to this is rational consensus on uncertainty quantification using expert judgment. So we come to the end of this little video. This is Roger Cook, and I'm signing off. And I wish you a lot of fun in the follow-up on this course.